What's up guys, welcome to my channel. In this video I'm going to teach you about work, energy and power, and if you want to know that, make sure to stay tuned. So the first one I'm going to teach you is about work, and work is the action in which a force is exerted in distance. I've uploaded a video about force, and you can use that to get the simple details, because we're going to have force in the title of work. So work is the ability to do force in some distance. For example, assume this is somebody that's trying to move a block through this distance in some amount of force. So a force is just the push or pull of a body made by another body, but work is push or pull made by a body that gives it a distance. For example, this guy moved this block by pulling it through his shoulders to this distance. So the distance between the initial point and the final point is the thing that makes it a work. And the other thing is that you have to notice is that, for example, if someone is lifting up a block from here, and if he holds it above his head, and if he moves it until this place, he actually didn't do work, so you can't tell that he did work from the initial point until the final point. So you can say that this is the work's distance. This is because when you're doing work, the gravity and your force must be perpendicular. In the previous example I've showed you, before this example, I showed you that someone was pulling a block through his shoulders, while the gravity is acting downwards and his force is acting sideways. So you can say that this is perpendicular. That's when force is created. But in here, the only thing he did is just lift up the block and just keep going while he's holding it over his head. So that means the force is upward and the gravity is downwards, which is not perpendicular. So you can say that this guy didn't do any force. He didn't do any work. So the formula for work is that the symbol is actually W, which is a scalar quantity, not a vector quantity. W is equal to, you can easily note it, so you can easily comprehend it using the examples I've shown you. So it's force multiplied by distance. So I told you that work can't be done if it's perpendicular. In this case, the force and the gravity must not be perpendicular. So using the units in here, we can see that force has a unit of Newton, the SI unit, and this and distance has a unit of meter. So we said that Newton is kilogram meter per meter square. Kilogram meter per second square times meters. So when you multiply these, you'll get kilogram meter square per second square, which gives us joule, and it's denoted by J. It's the SI unit of work, and it was found by James Prescott Joule. So let me give you some questions, and let's go to the next part, that is energy. So the first question is, a person was pulling a block with 70 Newton for 5 meters. So how much work did he do? Using the formula I've given you, you can easily answer this question. So pause the video and do it. Okay, so the given ones, I'm going to answer you this question. The given was the force, which is 70 Newton, and the distance, which is 5 meters. And the required was the work. So the solution is that W is equal to F times S, which is force times distance. And we said that the force was 70 Newton. And the distance was 5 meters. So 70 times 5 is 350. And Newton times meter is joule. So we can say that the work done is equal to 350 joules. I'm going to add 2 more questions. So the question is, a woman had a work done of 600 joules. She applied a force of 25 newtons. So how far did she go? I just gave you the formula. You just have to substitute some of the physical quantities. So try to do this question and by pausing it, and I'm going to tell you how to answer this question. So let's take out the given card and the solution in here. So the given was the work, which is 600 joules. And the force, which is 25 newton. So the required is the distance. So the formula is W is equal to F times S. But we don't have the distance here, so we just have to substitute these. So I can divide both sides by force. And then these cancel out, so we can easily know that the distance is equal to the work over the force. So the work is 600 joules and the force is 25 newtons. So when you do this, you eventually get an answer of 24 meters. So the answer is 24 meters. So I'm going to give you one last question and I'm going to end this video. We'll talk about energy and power in the next 2 videos. So it says a person was doing 240 joules of work. Find the force if he applied it for 8 meters. Just like before, you just have to substitute some of the quantities. So pause the video and do it. So the given in here is the work, which is 240 joules. and the distance, which is 8 meters. So the required is the force. So W is equal to, so if I want to know the force, I just have to divide both sides by the distance, and we can come and see that F is equal to W over S. So W was 240 joules and the distance was 8 meters. So 240 over 8 is 30. But how can you know that joule over meter is Newton? So we just have to break it up to its fundamental quantities. Kilogram, meter square per second square times 1 over meter, which is divided by 1 meter. So these two cancels. This means m times m. M squared means m times m. So m cancels with m. So this exponent is no longer here. So we can come with kilogram meter per second square, which is Newton. So this is equal to 30 Newton. So that's it for this video, guys. If this video was helpful, make sure to like, and if you are new to this channel, make sure to subscribe, and I will show you the next two parts in the next two videos, which is energy and power. Bye.